In this video, we will be identifying functions from a graph. An input-output machine generated the table below and it did not represent a function. Justify this with a graph. Recall that the set of ordered pairs 1, 7, 2, 8, 2, 11 is not a function because the number 2 in the first set of elements associates with more than one number in the second set of elements. But now let's graph these ordered pairs. Here's a grid. Here's 1, 7. Here's 2, 8. And here's the ordered pair 2, 11. Notice these 2 points both lie on the same vertical line. This can help us assess if a graphed relation is a function visually. This is called the vertical line test for a function, abbreviated VLT. Here's more on the vertical line test. A graph represents a function when no 2 points on the graph lie on the same vertical line. You can do a ruler slide test. Place a ruler perpendicular to the independent axis, the x-axis, and slide the ruler across the graph, keeping the ruler perpendicular to the x-axis. If the left or right edge of the ruler intersects the graph at no more than 1 point, the graph is a function. So here's my ruler. We're going to slide it to the right. And you can see that this ruler intersected these 3 points. That's more than 1 point. And you can see that these 3 points lie in a vertical line. This graph fails the VLT. In this example, this graph does not represent a function. Let's do another example. Use the quadrupling machine below to generate a table of values for natural numbers. Is this a function? We've generated these ordered pairs before. In this case, x is a natural number. So if we put in 4, it will get quadrupled to 16. We put in a 5, it will be quadrupled to 20. We now have 5 ordered pairs. The table will continue for all natural numbers. The domain is the set of natural numbers. The range is a set of natural number multiples of 4. So here's our table of values, and here's a graph representing this table. The equation is y equals 4x, where x is a natural number. Here's our ruler. We're going to slide it to the right, and we'll notice that it only intersects in at most 1 point. So this graph passes the vertical line test. In this example, this graph does represent a function. Here we were dealing with a discrete graph. Later we will deal with continuous graphs. Here's a second example. The quadrupling machine was once again used to generate a table of values for real numbers. Is this a function? Here's a table of values. It looks very similar, except now the left column still representing x, but now x represents real numbers. So the domain is the full set of real numbers. The range is the set of real number multiples of 4. Producing the graph, now we can play connect the dots and have a solid line passing through these dots. The equation is still y equals 4x, but here we are dealing with a continuous graph, simply because the domain is all real numbers. Here's our ruler. We slide it to the right, and it still only hits in at most 1 spot. So this graph passes the vertical line test. In this example, this graph does represent a function. Here's some practice. You may wish to hit pause here and try this all on your own. Is the relation represented by each graph a function? Let's look at A. Here's our ruler. We'll slide it to the right. Notice these 2 points both lie on the same vertical line. This graph fails the vertical line test. This graph does not represent a function. Let's do B. Here's our ruler again. Slide it to the right. Looks pretty good. Notice no 2 points lie on the same vertical line. This graph passes the vertical line test, and this graph is a function. Please proceed to the next activity in this lesson. Thank you for viewing.